Okay, this is page 5 of the 3-1 notes, and now we're going to start applying the exponential functions, the exponential growth and decay functions. And one way that you can apply this is through the compound interest formula. If you have some money, which is called the principal, and you invest it at an annual interest rate, and for our formula we'll have to have that interest rate in decimal form, compounded so many times a year, that's going to be the N, then the balance, A, in the account after T years is given by this formula. So P is the amount invested, or the principal, R is the interest rate in decimal form, N is the number of times per year that it's compounded, and then T is the number of years. And that will give you how much money you now have altogether. Alright, so I'm having a little trouble here. Technical difficulty. Okay, this is not good. Okay, that's not going to work. I have to go over here and do it this way. I hate doing it this way. Okay. Alright, so on example 4, there's 3 parts, A, B, and C. Christy invests $300 in an account with a 6% interest rate, making no other deposits or withdrawals. What will Christy's account balance be after 20 years if the interest is compounded? And we're going to see what it would be if it's semi-annually, monthly, and then daily. So basically, she's going to put $300 in there and then just let it sit and draw interest. She's not going to take anything out and not going to add anything to it. So the principal, the amount being invested or being put in, is $300. Okay, hold on just a minute. I don't know why that is there. Okay, well, that gets it off of that. Alright, then our interest rate as a decimal, the R, is 0.06 because the interest rate is 0.06. Alright, I'll need to write a little bit below that box. Okay, and then our T is 20 years. Okay, now our N is going to change with A, B, and C. So N is the number of times per year that the interest is compounded. So semi-annually, N would be 2. So we're going to plug this into our formula, our compound interest formula up here. A equals P times 1 plus R over N to the NT power. So A, we're finding A, the balance we would have, equals P, 300, times 1 plus R, 0.06, over N, 2, to the NT power. N is 2, T is 20. Okay, so if you plug that into your calculator, you would get $978.61. Okay, so let's move down. And if we compound it monthly, your N would be 12. How many times per year is monthly? Well, that would be 12. So we're going to use the same formula. A equals, the principal still the same, 1 plus, the interest rate is still the same. Now our N is 12. So then we would have NT up here would be 12 times 20. And if you put that into your calculator, you should get $993.06. okay? And then daily. And over here in this box, it tells us that for daily compounding, we're going to use 365. So how many times in a year is it compounded? 365. That's our n. So A equals 300 times 1 plus 0.06 divided by 365 to the 365, that's your n, times 20, still 20 years. So it's a pretty big power there. And that would be $995.94, I believe. Okay. All right. So on the next page, there's a table. And it's basically that problem. And of course, we did the semi-annual, we did the monthly, and we did the daily. But then there's some others here. There's the annual, quarterly, which would be 4 times a year, and then hourly. And you can see that the jump is bigger here than it is when you get up here. So the difference between compounding daily and hourly is just a few cents. Okay? So that leads us into continual compounding. Okay, and that's where we're going to use our E. So P is still going to be our principal. The interest rate, R, is still a decimal. T is the number of years. But notice there's no N because we're not compounding so many times a year. We're compounding continually. So that's why there is no N. Alright, so we're going to use that same problem, except now Christy is compounding, or her $300, the interest is being compounded continually. Alright, so A equals P E to the RT power. Whoops. Okay, so A equals, our principal still 300, E to the R is still in decimal, so 0.06 times 20. And if you put that in your calculator, use your E button, you will get $996.04. So be sure you try it on your calculator. Okay, so let's see what's next. Okay, now we're going to get into exponential growth or decay formulas that may not be just dealing with money and compounding interest. And I'm going to stop this video and start this next section in a separate video.